First thing that we have to configure is uploading the headshot to an Azure Storage Explorer. So let me switch back to the Azure portal and we have our storage account. If we examine the containers there, we have quite a few containers. But here I will create a new container with the name function sales rep and will give this a container access so it can be accessed without key. This is the container where we should be uploading the headshot images. So let me hit the create button and that container is created. Now that the container is created here, let's add the code in our application so we can upload items to this container. We will switch back to the application and inside the home controller of our web project, we will open the index view. There, rather than upload resume, we will call this upload headshot. Next, we have to work on the home controller because we will be retrieving an image here. If we examine the index view that we already have ENC type of multi-part form data and we are asking for a file input. So we can extract that input directly here. With the sales request, we will also receive an iForm file. This process we only want if the file is not null, then let's proceed further. The first thing that we have to do is we have to change the name of the file to be the ID that we have right here. So we will say file name is equal to salesrequest.id and we want to use the same extension that the file has. Then in order to work with blobs, we will need a blob service client using dependency injection. So let me configure that right here and we will have to add the NuGet package Azure Storage Blobs. With that, we will have a blob service client that we can use. To avoid the confusion, I can just call this as blob service client because blob client can be confusing. Perfect. Let's go down to our index post action method. On the blob service client, we have to create a blob container client. We will call that blob container client is equal to underscore blob service client dot get blob container client. We need to pass the container name here. So if we go back, that name is function sales rep. Then from the blob container client, you will have to retrieve the blob client using the method getBlobClient. Last thing that we have to do is we need to configure the blob HTTP headers. So HTTP headers is equal to new blob HTTP header. We'll do control dot for the using statement and the only parameter we will populate is the content type. So content type will be same as file.contentType. Now that we have the blob client, uploading our image should be super simple. We will just await on blob client. We have the method there, which is upload async, and we have file. We just need to open read stream, and we have to pass the headers that is inside HTTP headers. With that, the image should be uploaded and we will return back to the view. So perfect, our image upload logic is working as expected. Now we can work on adding the resize image Azure function. Let's do that in the next video. As soon as a blob gets uploaded, we want our new function to fire and we want to resize the image and push that to a new folder. So let's switch back to the application and let's go to Solution Explorer. Let me add a new Azure function. I will call this resize image on blob upload. Let's add that. This will be a blob trigger because once we upload the image to blob account, that time the trigger should fire. We need the connection string setting name. That will be the same default name, which is Azure Web Jobs Storage. And next we need the path. If we go back to the Azure Storage account, we know the container name is function sales rep. So let me paste that here. And we will configure the path a little bit more, but let's first hit the add button. So this time you can see the trigger that we have is blob trigger, and then the name is container name, and it automatically appends a variable which is name of the file or blob that was uploaded. The connection name looks good, and we have the stream which is my blob. When we receive the my blob here, we want to resize that. So first let's retrieve that image right here. We will be using 6 labels image resizer. So in image, when you type RGBA32 and you press Ctrl dot here, it should display the package which is 6 labels image resharp. That is the package that we will use to resize our image. Here we will call this input is equal to image, and we need to add the using statement. Make sure to add 6 labels dot image sharp and nothing else. On there we have the load method with RGBA32, and here we can pass 2 parameters. The first parameter is the image here that is inside my blob, and next is the format. Format, we will use the image format, and we'll add the using statement. Let's call that as format. This format will actually be the output, and when we get this image format output, we will be resizing our image. Resizing is super simple. On the input, we will call the mutate method to resize, which is inside image_sharp.processing, and we will give the new size here. So x.resize, let's say we want 300 by 200. Once we mutate the image, we just need to save that. So we'll say input.save, and we need the output path first, and next we can give the format. So here we'll have to provide the output path, and the format will automatically format and save everything. Right now we are getting an error because this is a string. It should be a stream object, just like my blob, where the output has to be returned. So that will be the output for our Azure function, and we will have to add that in the parameter here. If you examine the other Azure function, here you notice that we were using Q for the output. Now this time we want to write to a blob. So for that, we have a special output here, which is blob. We have to define few parameters. First is the blob path. Let's use the same path this time with the name. But this time, let's also append sm for small. This will be the container name, so it makes sense to go back and actually create that container in our storage account with container access. Perfect. Let's go back now. And with blob, you can also give file access. We will give it the right access. This will be a stream object, and we can call this my blob output. So this is where the output should go. We will paste that here, and the error should go away. So you can see how easy it was. We are retrieving the name here. We are using the same name. So that way it is smart enough to use the same name. It will just post that to a different container. So with that, our Azure function looks great. Let's run the application and test it out. When we run the application, make sure to run the function as well as the main project. And when we run that, we get the error with Blob Service Client because we have to configure that. So we have to do that inside the program.cs of the web application. We need to copy the connection string. So let's go to local settings.json from Azure and copy the connection string. We need the Azure storage connection string. Let me close that. And we first need to paste that inside the app settings.json file. Then inside program.cs, we have to retrieve this connection string and populate the blob service client. So on the builder.service, we will add another builder.addSingleton. This will be the blob service client. We will add the using statement, and we have the configuration where we will retrieve the value of Azure Web Jobs Storage. That's the exact name that we have, so that should work. With that in place, let me run both the applications one more time. Perfect, this time you see we have a blob trigger as well. Now before I submit the application, let me add few debugging points. First one will be inside the home controller to make sure that upload is successful. And then on resize image blob, let me add a debugging point right here. Then let's go back and let's upload an image. Let's hit the apply button. We hit our debugging point here, so blob will be uploaded. Let's go back and let's examine our function sales rep. Great, we have the blob here. Inside the edit, we see the complete blob and the size is 63 kilobytes. Let's go back to the application and hit continue. We should hit the breakpoint in our resize function. Let's hit continue here and see what happens. Perfect, we are redirected back. Let's go to the storage account and let's examine the container, which is the small one, and edit. The image is the same, but the size you see it's different. This is only 33.67. So great, we can see our resize is working as expected. And if you examine in the logs, we have all the Azure functions that were triggered. We have the onSales upload, write to queue. We have the onQueue trigger, update database, and finally resize image on blob upload. So with that, our resize function is working as expected. Let's continue in the next video. Now our resize image is working as expected. Next function that we want to implement is update the status in database once the resize is done. The way I want to implement this is when an image resize is completed, it will add the image inside this new container. So we can create a new blob trigger on this container and we can update the database. I want you guys to pause this video and give that a try as an assignment. That should be pretty straightforward because we already know how to update the status and how to create blob trigger. The status I want you guys to update to is image processed. So pause this video and give that a try. I hope you guys were able to complete that. If not, let's do that together. Let me switch back to the application, remove the breakpoints that we added, and let me close all the tabs. Let's stop the application and let me open up the blob trigger resize image on blob upload. This time we will be adding a new Azure function. I will call this blob resize trigger update status in DB. Let's add this function. This will be a blob trigger. The connection string setting name is the same Azure Web Storage Jobs, and we need the path. If we go back, we have the path right here for the container name. Let me paste that and hit the add button. We need to update the status in database. For that, we will need the Azure Tangi DB context using dependency injection. Since we are using this, the class will not be a static class. Let me remove that. If we examine all the parameters here, you see we have a string parameter name. What happens is the name that we are using here, that is binded automatically with the string name. Inside the onResize image, we were using the name inside the logs and nowhere else. That's why I forgot to show that. But here, if you have dynamic variables like this, you are binding that to the variable, then you need that same variable name inside the parameters. Azure function, when it creates, it automatically does the binding, but you should always remember that. If you are using any of the variable here in parameters, you will need that inside the parentheses, then you will need that exact variable in parameters for the run method. Now if we go back to the container and we examine, I told you before that name of this image will be the same name as the ID of the record in the database. So we can use this name to extract the record from database. So first thing that we have to do is we need to find the name without the extension. For that, we will be using path azure.getFileName without extension method, and that will retrieve the file name. Next, we need to get a sales request object from database based on the ID. We will use the using statement. I will call this sales request from db is equal to underscore db dot sales request dot first dot default. We want it based on the ID. So u.id is equal to the file name. Then we want to update the status if this is not null. So if sales request from db is not null, in that case, we will update the status. We will set that to image processed and we'll say underscore db dot sales request dot update. We want to update the sales request from db and we will save the changes. So you can see how easy it is to write powerful functionalities within Azure Functions, and they are so quick. With this in place, now the database should be updated. Let's add a debugging point here and run the application. As soon as you run the application, it will hit our breakpoint. Why did this happen? We did not upload any image. The reason it happened is inside our container, we already have a new image. So it automatically detects this image and it is hitting that breakpoint. You can see the ID is 1131. If you see the name, that is the same. So it found out that there is a new entry. I need to do some processing. Let's see if the status is updated or not. You can see the logs here. Let's go back to SQL Server and let's refresh. Great, you can see the 1131 is updated to image processed. So that is working as expected. Let me try to upload one more image. Let's hit the apply button and see what happens. We hit our breakpoint again. Let's hit continue. And if we examine the logs, you will see all of the Azure functions were triggered right here. Let's go back to the database and execute this. We have a new record right here. Let's go back to our container. If we refresh, we have the new image as well. Let's go, edit. Perfect. Looks good. So with this, our update status in database is also working as expected. With that, let's continue in the next video. Now we need to implement the last Azure function, which will be a timer trigger. Every 5 minutes, we will check if there are any records in the database with the status of completed. Every 5 minutes, we will check in the database if there are any records with the status image processed. If there are, then we will update their status to completed and we will send an email. Now, in order to send email, I will be using SendGrid, but I will not show you how to create a SendGrid account and how to get the API key. I have shown that in many of my .NET Core courses, but with SendGrid, you will need a sender identity and it is working only if you have domain email. If you use Gmail or Yahoo, it won't work. So that is beyond the scope of this course to get you started with a domain email and make sure SendGrid works. So if you have a SendGrid account, you can always test that with the application, but my main focus is to show you how the timer trigger works and how you can configure few things. So let me switch back to the application, stop the debugging point and the application. We will add a new Azure function. So add, I will call this Azure function update status to completed and send email. This will be a timer trigger. Now when you are working with timer trigger, you have to set a schedule. This schedule basically denotes how often the function should be triggered. And what we have here is a cron tab expression. This expression basically means that the function should be triggered every 5 minutes by default. You can always change that if you want. Let me hit the add button and let me open up a documentation on the Microsoft website. Here it displays what cron tabs are and few examples of how you want to configure the cron tabs. I will not go into much details, but you can basically play around with the examples to see how you can configure the cron tab. We are using the default one, which is once every 5 minutes, and you just need to write your corresponding cron tab inside the parameters of timer trigger. Now here, when the timer expires, we need to access the database to find out all the records. So we will add dependency injection for our DB context. We need to remove the static class and the method. First thing that we have to do is we need to get an IEnumerable of sales request, and we will retrieve all of the sales request where status is image processed. Then for each of the object that we retrieve here, we have to set their status to completed. If you want to do something else here, that can also be configured. So right now we are only updating the status. You can always use a link expression, but I kept this simple. Once that is done, we can update everything. So _db dot update range, and we want to update all of the requests from database. Finally, we will say _db dot save changes. With this, all the status will be updated to completed. Now this is sufficient if that was the only requirement, and we can run this and test it out. But as an add-on, I want to show you how to use SendGrid to send an email with the Azure function. That is pretty simple. I will first log in to my SendGrid account. And if I go to the Settings tab, I have API keys that have been configured. Now, of course, the API key is secret and it is not visible. I will not be creating a new API key, but I already know my key and I will be using that to send emails. I have said that before that if you use Gmail or Yahoo, this won't work. If you go to the mail settings here, not mail settings, sender authentication, you can see I have a verified domain, and that is why it will work for me. You need to verify your single sender, and after that you will have to create a key, and that key is what we will be using. So if we switch back, let me open the local settings.json, and I will be creating one more key. The name I am using is custom SendGrid key app setting name. I will copy that, and the key is right here. Next, we need to use this key in our Azure function. So right here, after the timer, the output will be a SendGrid. So we will have to use SendGrid here. If you press Ctrl dot here, we do not see the SendGrid option. So I will have to add the NuGet package manually. Now when you browse for the package, this will not be the typical SendGrid package. SendGrid has a package with the web jobs, and that is what we will be using. So right here, you see Microsoft.azure.webjobs.extensions.SendGrid. We need to use this package because all the bindings of SendGrid will automatically be done. So let's install this package. If you use the regular SendGrid package, then you will have to work with initialization, injecting that in the program class file like we did with the DB context. But with this package, everything will be configured and we just have to pass the API key. Here we do not need the exact key, but we need the name where we have stored the key inside the local settings.json. And then to send the message, we will have an IAsync collector of SendGrid message. We will call that as message collector. Let me add the using statements here, and the errors should go away. Perfect, everything looks good. Now the output of this Azure function has been configured. We can use that right here. First thing, we have to create a new SendGrid message. And then we have to configure the email address where we have to send, what is the content from email address, and the subject. After the message has been configured, the last step is to send the message, and this is an async method. So we need async and task. Looks good. Now let me add a debugging point on the timer, and let's run the application. This time we do not want to upload anything because we already have the data. We just have to wait for 5 minutes so that our timer trigger is invoked. In the meanwhile, let me go to SQL Server and execute this. We have 2 of them with the status image processed. Let's wait for the timer. And perfect, it hits our timer. Let's hit continue. We see the status here, it has been updated. Let's go back and see what's the status. The status now is completed. Let me also pull up my email. Right here we have received the email with the configuration. So with that you can see how SendGrid is working as expected. The count here is setting to 0 because we are updating everything, but if you want you can store that to a variable and then add that for logging. But basically you can see how timer triggers are working and how we can send emails using SendGrid. Now Azure Function is not just limited to what we have inside the triggers. You can see sometimes based on the output bindings, you can customize that and inject some things to dependency injection, just like a .NET Core application. When it comes to Azure Function, it is a very powerful tool and you can do lots of things with a very small functionality. We want to create a RESTful API function to perform all the CRUD operation. So the first thing that is needed for that is to create a model for that. We can reuse the sales request, but I want to start with a new model. So we will add a new class inside our models folder in the Azure Tangy function. I will call that grocery item and let's add that. We will make this a public class and in there I will add 3 properties, ID, name and created date. Now in a typical RESTful API, you have different models, one for database and one that you want to navigate within the calls. So let's say for create and update, we have an absurd model. Let's create that as well. I will call this grocery item underscore absurd. When an item is being updated, let's say we are only passing the name. The ID we will pass that as parameters. Now of course I'm not making the API more secure. My main focus is only to give you something that you can work with and enhance with Azure Function. Ideally you will also have ID here rather than passing as parameters, but how you architect API is not the focus of this course. So please do not pick on that. I just wanted to give you more examples with Azure Function, and that is the reason I have kept this very simple. We will make this a public class as well. Let's save that. Now that we have added both of the models, let's also configure our DB context to create a new DB set because we'll be storing all the requests. So I will call that grocery items and the class name is also grocery item. On the model builder, if you want, you can define the entity that grocery item has a key with the field of ID. With that, our DB context also looks good. Last thing that we have to work on is the Azure function itself. Let's do that in the next video.